Hey, do you listen to me? Is this sound good now? Okay, let's just. Hey, chat. If you hear me, just type anything. Oh, okay. So now it's good. Uh, oh, so we have to do the intro. Yeah. Hey, thank you, chat. So we have to do the intro. Oh man. Okay, so let's just let's just continue, and we're gonna talk about the video. Okay, so the problem is the maximum subsequence score. We're gonna continue working on the heap problems. So we have two lists, num1 and nums2. We're gonna choose from the num1 the k elements and sum them, and then we're gonna multiply them by the minimum of the k element of the other list and see which and return the maximum result. Okay, so so I think here we're gonna just I think there is already a predefined function to like we have combination of number of a list, so we need to uh, uh, list of like combinations. We're gonna iterate through it. So for nums in like for num in combination, we're gonna sum them like sum of combination multiplied by so here I don't think we need a heap because we don't have like smallest or largest or anything, but here I think we're gonna use it. So I think here we're gonna use the heap because we have the minimum, so we're gonna push into the heap the three numbers or the k numbers, and then we're gonna just pop the minimum. So okay, so push k elements into heap and then pop the last element, which gonna be the min, and then multiply it by them, and we're gonna say this is max and compare it every time with or max so far, and multiply it, compare it every time with max, and then we're gonna return the max. So I think this is a good idea. Okay, so let's just try the function like combination, I think, and if the solution works, uh, we're gonna try to solve it in another way, in a like iterative way. So I think combination and list, yeah, it is. So okay, test combinations iter tool. So okay, so combination of test2. Okay, what is it? Okay, so let's go to another way. Okay, so this is it. Ah man, I just want the predefined function. This is in Java. Okay, I'm gonna just use the predefined one. So the original list. Okay, x y in combination list. Okay, I'm just gonna make this. So like I said, we're gonna make a for loop in. So every time, how we're gonna do it? We're gonna iterate through the. I'm gonna make a pointer. So for e in range len of nums. So we have e I'm gonna make combination of, I have to input it, so from this amount. Okay, so this I'm gonna return a list. Okay, so nums of k. This is gonna return numbers. Oh, it's not k. Okay, so no, I cannot, because we don't know the index. Okay, so I'm gonna make the here we have 1 3 3 2. Okay, so I'm gonna make this I, and this is I plus 1, and this is I plus 2, and if the I is here, because I'll not know the indexes if I'm gonna use the predefined function. I have to every time have to. Okay, so I'm gonna say from I to. Okay, so every time I'm gonna make I minus 1 and I plus 1. For we have two edge cases, which is the start and the end. I have to make it I plus 1, I plus 2, and or we can stop like here, and this is from here. Oh no, we can do it. So we're gonna start from n. So for range 1, we're gonna start from 1 and len of nums. I think this is it. I'm gonna take the 3 numbers. Hey bro, hey, how are you? Welcome stream, man. So I'm gonna make sum. So I'm gonna call it s equals sum of. Do I think to make a list or? Okay, let's just try it. Nums of I minus 1 nums. Oh no, we have k. Oh no, I cannot. No. So it will be from I to like. Oh no, I cannot. So if it's k. No, cannot. Okay, so I think here we need a 2 pointers. Okay, so let's break it out. Have here I and here we have G. So G will start from I 1 2 and then 3. Okay, but if I is here, so G have to start from here. Okay, so G minus k. But I think I'm gonna make 2 loops for E, and then for G, like this is it, G, and then I gonna increment by 1, and this is it. And I can increment by 1. I am also going through the not get an internship, also don't have any degree but self-learning front end. It's very lesson of this is known or earning. Uh, don't give up, man. Just keep working hard, cause you just have to work, and the rest is it's luck, it's opportunity. So just work on yourself. If you want, show your try to make content or to show yourself to the people. Uh, Work a really good project. Make your GitHub better. Even me, I don't have the best GitHub and not the best project, not the best degree, but you just have to keep working until you find an opportunity. This is it. Or like, or do I have to just I and I plus k? Okay, and then increment I plus k, and then increment. No. Mm. How do I take the elements? Man, this has to be easy, man. It's the easiest part, like. I'm gonna need to. Okay. So, for A arrange. For G arrange. 03 or E3. No, not E3. Can I just use this, like the enumerate function? Or every time I push it, like the how okay, so let's put another one. So 1, 3, 3, 5, 6, and 7. Okay, how we're gonna choose this? And k equal like 3. So this 3. Okay, so how did he do it? He started from I, and then he chose those, and then 1, 3, 3, 2, and then the G plus 1. If G is at the latest, he increment I plus 1. 1, 3, 3, 1, 3, 2, 1, 3, 2, 0, 2, and 3. And here 0, 1, 3, 3, 1, 3, 2. So this one 0 and 2, 0, 1 and 2, 0, 1 and 3, and then 0, 2 and 3. I really don't know how to do it. How am I supposed to do this? combination, it is a list with index, with indexes. To print pairs. Pair from indexes. Pair from pairs. Iterator tools. A2. So this two, but I will not know the index. This to bring the combination, but I will not know the indexes to work on it with the second list. So we're going to do like combination for make a combination do for Filipinos a+1 doubles to depend ab no range 1 2 on 7 no just don't the indexes. The problem is the index. So this R, this G, okay, so G, and then, or do I have to push it, like, push those? I push it onto a, do I have to push it into a heap? This? I push 1 3 3. I think we need 3 pointers. 3 pointers. Like, can we do the 3 pointers? AG and K? No, let's try T. It's T. Every time we increment one of those, it will be a repetition, but does it matter? Okay. So let's try to put it in a. We're gonna use 3, I think. So for range, it's not okay. So it's not 1. It's but we cannot sum the same for G if okay. So for G in range, then of nums, and we're gonna make a condition. Okay, and then I think this the best thing to solve a problem. I'm gonna use 3 nested loops. So and we're gonna make condition to not like sum the 3 numbers, which is, so we cannot, so if E doesn't have to be in the same place at G and T. So okay, so if so I'm gonna use if E different of G and E different of T and E different of and G different of T and okay, I think this is it, and A different of G and different of T, like okay, so E is not okay, so I think this is it. G different of E, T different of E, G different of E. Okay, so we're gonna sum those 3. So sum of E and sum of nums of G and nums of T. After we sum them, we're gonna push everyone. So let's define a heap queue. So I'm gonna make min1 equal and let's import heap queue, and then heap queue dot heapify min1. So now okay, and then I'm gonna push it k times. So here for no, it's not, no, why I'm using like, no, I cannot, no, this is impossible. I'm like working in the test case of like k equal 3, and yeah, no, this is so wrong. Oh, okay. Like this is so simple, man. I know how to make the combination, but the indexes are so hard to get. If I make an index, no, do not. Okay, so indexes 0, 1, 2, 3, 4, array 1 and 2. Repeating. Okay, so oh, okay, so like nothing. Program found combinations at the list. No. Index. Huh? What is this? No. it's not it. Here I'm creating a dictionary where each item is mapped again. What character attributes from one nation can for an item system. Two. Combination. Okay, so not combination in situation I therefore. Okay, so I'm not understanding anything. So what is this? Oh, yeah. So can we test this? Diff, and then. It's like this can work, I think. Oh, but this whole I think it's not that complicated. Okay, so I manage and chat documents. Okay, so it's like 30 minutes and we identified the solution, but think like we said. Okay, so we're just gonna. Okay, can we look at how can we use sorting here? Sorting. Okay, we sort to get the minimum. But this, I'm gonna okay. Try sorting the two arrays based on second array. Nah, still don't get it. Loop through nums2 and compute the max product given minimum is nums2I. Update the answer record. Loop through nums2 and compute the max product given minimum is. Hey, hello man. Welcome stream. Don't know what medium is an appropriate assessment. It's very similar. Hell, the algorithm is essentially the same. Maximum performance of team. Probably be fair, label the field about relentless performance. Circle and then after vector. Then it's usually good with you. But this one slapped me around. Try some priority cubable and this hits on sort the pair. Okay, I'm simply gonna watch the neat code thing. I really didn't get it. Okay, so it's not the end of the world if we didn't solve it. We're simply gonna learn about it. Okay. Do they want a job as current developer and I'll take along with you? Let's go. Hey, thank you, man. Good luck. Good luck with finding the job you want. Greedy plus implementation QoS rate from code forces will help building intuition. Yeah.
So that's sort of the restriction. Now, the way they phrase this problem is they call this a subsequence, which, yeah, it kind of is a subsequence from the array, but when we take these individual values and actually use them, we're not actually building a subsequence in the output. Like, from the first array variable, second, hint that this could be total output, which in this case is the total score, but we're not actually trying to minimize anything. Yes, we have to take the minimum from, we want to maximize the essentially not kind of more intuitive. We can solve this another way, a greedy way, but it's still not very simple or intuitive on how we can do that, because there are going to be cases where we have conflicting priorities, because there are going to be ideally we just want to maximize everything in the first array and maximize everything in the second array, but clearly here we have a choice. We can only choose this or we can choose this. So in the first choice, we favor having a larger N2. In the second, we favor having a larger N1. Now in this case, the result will be, by choosing this, the result I think will be 3. With this, it would have been 2. But you can imagine how complicated making that decision would be in a very large array. How to try to make a drawing board and try to consider some brute force approaches. Yes, the simplest brute force would be to sort of have a decision tree, but that would be exponential, and trying to add memorization to that would be difficult because there aren't really supernatural subproblems with this like array of numbers. It's hard to formulate that as a dynamic programming problem. The idea we can use is a little bit more simple. We know that in the second array, yes, we're going to take like a handful of elements, but there's only one of these elements that really matters, and that happens to be the minimum. So why not try to formulate the problem in such a way where we consider every single element as the minimum and try to find what's the maximum score we could get if 1 happened to be the minimum. Well, there's only a single 1, and we do need 3 elements. I don't think we can have less than 3 elements when we calculate a score. So in this case, we have to kind of keep adding. Well, which one would you rather add? The 2 or the 3? Well, it's kind of hard.
Oh, okay. Let's just. So 12 and 12 min of 2, 3, and 4. Also, the minimum here is not 1, it's actually 2. No, so we cannot get it. Okay.
Hard to say the way we're going through this right now because we're starting at the smallest. Why not try to be greedy like I mentioned earlier? Why not start at the biggest and say, what if 4 is the minimum in the second array? What's the maximum score we can get then? Well, there's only a single 4, so that's not even possible. So naturally, the next question to ask would be, what's the maximum score we can get where 3 is the minimum? Why is that the natural question to ask? Because we already have a 4, and if we add a 3, we've updated our minimum to now be 3. Now, finding those elements in order is not going to be easy unless we actually sort the arrays, but we know we kind of have to keep that one-to-one mapping for elements from the first array to the second array. So what we do is create an array of pairs, but then sort the array in descending order based on the values from the second array. So when I take this and sort it, the output would look like this. So getting rid of these first 2.
2, 3, 1, 2. 4, 3, 2, 1. Ah, okay, so this is sorted. What about this?
And the output is now going to, well, the input is going to look like this.
How's that is sorted? So this has to be the same index as this. Oh, okay. So 2 is 4, 3 and 3. I think he mean 3 here. 3 and 2.
Now I did draw it as 2 arrays, but we're going to do a single array. But
Okay.
now going back to that idea of for every single element in the second array, let's figure out what is the maximum possible score we could have where this is the minimum from the second array. We already know that it's not possible to do that for this. We just don't have enough elements with this as the value from the second array. So then we kind of expand. We have 2 elements now, and we're asking a new question. What's the max score where this is the minimum? Again, we don't have enough elements here, so then we keep going in this order now. Now we ask the question, what's the max score where 2 is the minimum? And now we finally have reached that threshold of k elements. So we can finally actually calculate a score. How are we going to do it? Well, we don't even have to keep track of the minimum because every time we add a new element, that is going to be the minimum from the second array. So it's not like we have to take the minimum of all these k elements. That's kind of the neat part here. So our minimum is 2 from the second array. And as we go in the first array, we probably should keep a running total, a running sum of each element. That should be easy enough though. So here we would have accumulated 2 plus 3 plus 1 multiplied by 2. That's going to give us a score of 12. Now that does happen to be the result in this case, but that was too easy. This is a pretty simple example, so let's kind of continue how we would continue to solve this problem if we had a much longer array. And we haven't yet asked the question, what's the max score we could get where 1 is the minimum? Now the problem here, of course, is that we have more than k elements. And I think this is probably the hardest part of the problem, at least in terms of the intuition, because now we have the difficult problem of making a choice. How do we make that choice? How do we know which one of these elements to remove? And I'll tell you the answer is simpler than you might think. We know that the calculation we're trying to make is taking the sum from the first array and the minimum from the second array. So my question is, we know 1 is the minimum from the second array. So does the calculation change whether we remove 2 or remove 3 or remove 4? What I'm asking is, does the calculation of the second portion change where we take the minimum from the second array? Not really. It's still going to be 1. We're still going to be multiplying 1 by the sum from the first array. So really, it doesn't matter which one of these we choose. So we shouldn't use the value from the second array to make our decision. It's irrelevant. It's not going to affect the score. What is going to affect the score is which one of the elements we remove from nums 1, because those are the ones we're summing up. That's the main idea behind this problem. It's not simple to come up with, but now that you see it, I hope you understand it. So now here, when we are making the choice, which one do you think we should remove? Probably the 1, because it's the smallest among all of these. If we are going to be removing based on the smallest from a set of values, and we always want our set of values to be at most k, a natural data structure to use would be a min heap, and that's what I'm going to be doing in this problem. Now before we code it up, what would be the time complexity?
We have to wait. We have to delete this. Okay.
Well, remember, we are sorting the input array. Let's say it's of size n. That would make the time complexity of sorting n log n. And that's going to dominate the time complexity. Yes, we're going to be pushing and popping from the heap, but each operation is going to be log k because the max size of the heap is going to be k, and n operations is going to be n log n. So obviously, in this case, n log n is going to be larger than n log k. And in terms of space complexity, I believe it's going to be big O of k if you don't count extra memory needed from sorting, depending on how that sorting is implemented. Now let's code this up. So like I said, the first thing we actually want to do is sort the array of pairs. We want to first build that array of pairs. Thankfully, this is pretty easy in Python. This is called list comprehension. So we're going to go through every pair of elements. And before we do that, we can actually zip the arrays nums1 and nums2. Unpack those variables. And for the array, we want to add a pair. I'm going to do it like this. This is actually a tuple. I guess in this case, it probably doesn't matter. You could also use like a sublist or just a tuple like I'm doing here. Then we want to sort this. So we want to do a slightly custom sorting algorithm. We want to pass in our pairs, and we want to sort it based on the second value in the pairs. So we can use a lambda function. We have to specify the variable with key for sorted. That's just how this sorted method works. If you want to sort it based on some key, you have to specify that. I forgot what this is called, maybe a named parameter or something like that. But we can pass in an inline function, aka a lambda function, which will take a single parameter, which I'm going to call p for pair, and it will sort it based on the second value in that pair, so at index 1. And we also would probably want to sort this in descending order. So we're sorting this in descending order based on nums2, and then we can reassign pairs to that, because I don't think this actually updates pairs, so we do have to have that line. Now, to build the min heap, well, initialize the min heap, it's going to be empty, and I'm going to keep track of 2 variables just to make things a little bit easy. Well, one, I think we definitely have to keep track of the sum, the n1 sum, and I'm also going to keep track of the n2 minimum, like this. So n1 sum is initially going to be 0. The minimum we can probably just set to float of infinity because we're trying to minimize it, or if you don't remember how to set it to float of infinity, another valid value would probably be to just take the max from nums2, but I'm going to set it to infinity. And for now, we're going to initialize our result, aka the max score, to 0. experience. But then we're just going to start going through every pair in our list of pairs. So N1, N2, we're going to unpack these from each pair. And first thing we want to do is just update our current N1 sum using N1. And while we're at it, might as well update our N2 minimum to be N2 min or N2. But I believe since we are going through this in descending order based on N2, we really don't even need to do that. And that also tells me we probably don't even need to keep track of N2 min. N2 is literally always going to be the minimum that we've seen up until this point. So I'm just now going to clean that up. So I think this is perfectly fine to do in a real coding interview. You don't have to like know exactly what you're going to do before you do it. I think it's okay to refactor on the fly. But now we know with every pair, the whole point of it is to add it to the heap queue to make sure, first of all, that we didn't go over. So first, let's update our min heap and push just N1. Remember, that's all we need to pass in. We don't even care about N2 because when we're deciding which element to remove from the heap, we only take N1 into account. So now, the first thing we want to check before we update our score is, have we gone over the length? Has the length of this heap exceeded K? If it has, we should probably pop from that heap. And we can do that like this. So this is the N1 that we popped, so I'm going to name it slightly differently. N1 pop, and this is also the value that we want to remove from our N1 sum. So we're going to decrement our sum by the N1 pop value. Of course, I can just move this variable up here, but I don't
Man, I don't know how lead could like classify problem, but I don't think that this problem is medium. I think it's hard, man. Well, maybe I'm not that based in heap, but like the use of heap is not the big of a thing in this problem. Will It's like logic. It's not like using heap.
there's anything wrong with being a little bit more explicit. Now we can make sure that our heap is a valid length, but it's possible actually the heap could be less than K. The length could be less than K, so also add an if statement to check that it's exactly equal to K, and if it is, now we can start updating our result, and we know we're trying to maximize it, so we're going to take the max of the current result as well as, remember the formula is N1 sum multiplied by the minimum from N2, which we know is going to be whatever we happen to push right now anyway. And I believe that is the entire code, so now we can just go ahead and return the result out here to make sure that it works. And as you can see, yes it does, and it's pretty efficient.
Well, I don't know what I think of, but honestly I don't think that this problem is medium. I don't want to like act weak, but man, it's not medium, man. I don't know, man. Isn't it the case that every iteration was included? That was not medium, unless one has seen it before. Thanks. Yeah, like I could, I can solve it before the stream and show up here knowing everything and solve it in like 30 minutes or 20 or like less, but now I'll never do this. By that I will cheat myself, but man, this is not like this is depressing actually. So, ladies and gentlemen, I introduce you the worst stream, the worst episode of the stream series ever. I really don't think that I'm gonna work this today by my voice. I think you can know that I'm pretty sick, and this look like I oh the description like it's like a pretty long problem, and I don't want the stream to be that long. Sorry everyone to like make like not. Hey, مجدي رقيق, hello. So you came in when we were going to finish the stream, like we're gonna finish the stream now, and you came in now. Welcome, buddy. So I think we're gonna end the stream now. Thank you everyone. I think we're gonna stream on Monday. I don't think tomorrow I'm gonna stream because like my voice is like I'm very sick. I don't know if I'm gonna be able to stream tomorrow or not. Thank you everyone. Sorry for making you wasting your time watching this bad episode. Thank you everyone. I hope I see you like Monday or tomorrow. I'm gonna schedule the stream anyway. Thank you everyone. Like usual, don't forget to follow me on GitHub. Don't forget to follow me on LinkedIn. I'm very happy to connect with you. I'm very happy to talk with you. Don't forget to join our server Discord. So I think this is the end of stream. Thank you everyone, and see you the next stream.